I'll go ahead, by way of introduction, my name is Lee Howard again. I'm the Director of Network Technology at Time Warner Cable. So my job is to look at new and evolving technologies, things that are a couple years out. When I started working on IPv6 for Time Warner Cable, it was still looked like it was a couple of years out. Cool. So, and part of my job in that capacity has been to, as I've said a couple of times, analyze the alternatives and figure out what's the best strategy. And a lot of the work that I've done in figuring out the best strategy, I think, is really applicable to a lot of different companies. So what's the right strategy for anybody? I can't tell what any individual company strategy is, but I can maybe show you some ways to think about what some of the different costs of different possibilities are so that you can do your own math. One of the things that I like to say internally is that my job is to make sure that my executives make well-informed bad decisions. So I can't control what decision anybody's going to make, but at least you can be well informed as you're making that decision. So I'm basically going to talk about three different things. I'm going to talk about what it costs to use Carrier-Grade NAT, and that's based on the total cost of ownership of Carrier-Grade NAT talk that I did at last year's North American V6 Summit. I've refined it since then. There's additional work in there. I'm going to talk about what it costs to run dual stack. That's based on a presentation I did at the last NANOG, although again I've added, actually I think it's a much more interesting talk now, and what it will cost to buy IPv4 addresses. A lot of guesswork in there, and it's all brand new, so I can't wait to see what you think of it. Each of these is a 45-minute presentation, and I have 30 minutes. So when I was thinking about, a couple of years ago, I was thinking about, well, people keep talking about Carrier-Grade NAT breaks things. It's a terrible thing. Why is anybody even going to do it? Well, IPv6 is so much cheaper. And I had to say, well, is it really cheaper? How would we know it's cheaper? Well, because CGN breaks things. Well, how much does it break, and how do we quantify the cost of what's broken? So I sat down and I looked at, there's down here at the bottom, Draft Donnelly NAT 444 impacts. Actually, I'm a co-author on that document. I had a summer intern work on a couple of Carrier-Grade NAT boxes and do a bunch of testing and test all the applications that I could think to buy and have him test. He had it this summer. He was playing PlayStation and Xbox. He had the best summer internship ever. And he found that a couple things broke. We then had Cable Labs did some further testing. And so we've written this internet draft that is advancing along the process now. We found that things, so at the time that we did our testing, Xbox head-to-head games didn't work through Carrier-Grade NAT. And that was a fairly significant problem. Since then, Microsoft has actually deployed probably Stun, and their games seem to work now. So I've taken them out of this slide. But the PlayStation 3 head-to-head games still seem to have problems. Peer-to-peer networking has problems. Specifically, and this is because if you know what Carrier-Grade NAT is, when you're behind a NAT, if you don't have port forwarding, some way to indicate that you can be reached through that, it's difficult for you to publish content. So it's difficult to be a web server or to seed content on a peer-to-peer. Well, not everybody wants to seed peer-to-peer content, which is part of the problem with peer-to-peer, which is why the peer-to-peer networks often say you can only leach a certain percentage of how much that you seed. So eventually your ability to leach can be impacted by your ability to seed, and so even customers who don't think they care about seeding peer-to-peer actually do care about seeding peer-to-peer, which is why I've included it. We also found that some cases with Netflix didn't work very well, where you had multiple users behind the same IP address streaming Netflix. It was particularly bad behind one particular home gateway, but in several cases, Netflix performance was basically unusable after even just a half a dozen different virtual homes were streaming Netflix. So I went and asked the internet, how many users? Let's say I do a CGN with 10,000 users. How many users are affected? I need to know the significance of the extent of the problem before I can figure out what it costs. So I found that out of every 10,000 users in North America, about 1,100 will have PlayStation 3, about 1,500 will be doing BitTorrent or something like that. Probably 1,200 have Netflix, and let's say there's 800 of them are doing some of the other things that sometimes break, some of the more obscure voice over IP clients, other things that we just haven't encountered. Then how many of those, so then I made a guess. I said, all right, let's say half of PlayStation 3 users do head-to-head gaming. That's where I got 550. That's a guess. This spreadsheet is available online at I think I've got it, oh yeah, they're down there at the bottom, www.asgard.org/documents.html. You can download some slides and a paper and the spreadsheet and do your own math, plug in your numbers and figure out what the cost is for you. So I said, let's say half. I said, let's say more than half of peer-to-peers is because frankly, it's all peer-to-peer seeders, and therefore that's how I get to more than half. Some small percentage of Netflix users, because it depends on your ratio of compression and how many are using Netflix at a given time, and it's worse with certain home gateways for some reason I don't understand. But all of the miscellaneous problems are miscellaneous problems. That's why it's all 800. Okay, let's say that of that fraction of customers who are affected, who are using those applications in a way that is impacted by CGN, let's say that half, what did I say? No, 25% call tech support, and 25% cancel. Might be the same 25%, might be different 25%. So that's how I get to those different numbers. So what I said is if you deploy CGN for 10,000 users, you could expect something like 652 tech support calls and 652 lost users, people who cancel because you've broken things that are important to them. Is that the right number? It's logic. You can do your own math. It's a spreadsheet, but it's something, you know, okay, so some users may cancel because you're breaking their stuff. 650, maybe it's 300, maybe it's 700. Do your own thing. What I really want to show is sort of a way to think about this, because that's really significant. If out of 10,000 users, 650 cancel, that's what, 6%? I mean, that's a significant cut in your growth rate. So let's talk about the actual costs, the hard costs of CGN. I'll come back to, and I'll get back to this one. For the retail prices of CGN boxes that I've looked at are running about $90,000 for a 10,000 user CGN. Now, that's retail, and that's really approximate, and that's an average of, I think it was 3 different vendors I talked to, and those prices may change over time. So again, it's plug in your own number. Call your favorite CGN vendor, ask them what the price is, plug in your own number. I say system support, maintenance, that includes things like power, space, cooling, people sitting in your NOC watching the alarms when they go off, you know, people doing the cleaning and the care and feeding of your CGN. And then I say, okay, I actually went online and I said, what does a tech support call cost? And the costs were somewhere between, depending on whether you offshore or in-house your tech support, between $5 and $35, I think it was, for an average tech support call. So I picked 20, and I said, okay, $20 per call times 652 calls is $13,000, so you can spend some money on that. But here's the big one. If you lose 652 customers, I looked at the annual reports of the 4 largest residential ISPs in the US, AT&T, Comcast, Verizon, and Time Warner Cable. And I said, what's their average revenue per user? ARPU, if that's a new word for you, it's a cool word, ARPU. The average revenue per user for them was $400 per year. And I said, okay, if you lose $400 times 650 customers, that's $260,000. That's pretty significant. That's actual money. But that's just sort of 1 year's look at it. What's the cost over time? Let's say you're going to use CGN for 5 years. So let's mark it out over those 5 years. What does it actually cost? Well, your CapEx, you're going to depreciate it over 5 years. Your OpEx, well, you have to keep paying your, and I did straight line depreciation. You can do, you know, double down, whatever you want. OpEx, you still have to pay your support guys. You have to pay, you know, cooling and power and all that. So that keeps going. Customer support calls, those problems probably only occur once. I mean, they'll probably only call you once about any given problem. So those probably stop or taper off for a given body of users after the first year. The real one that kills you is the lost customers who aren't paying you revenue for each of those 5 years. So that's really where it adds up. So the number I get to is a pretty shocking $1.5 million for every 10,000 users. That's $30 per user per year that CGN costs you, the total cost of ownership of CGN. And I just sort of was plugging in numbers, not when I was first working on this, plugging in numbers not knowing where I was going to go. And I came out and I went, $30 per user per year? That's insane. And so then in the original presentation, I go back and I look at comparing that to your other alternatives like buying addresses. I think I'm going to come back to buying addresses. But if it's going to cost you $30 to run Carrier-Grade NAT, and it's going to cost you $12 to buy an address, that might actually be a cheaper option. right? That's a really surprising conclusion for me to have reached. It was surprising to me, at least. All right, cost of running dual stack. So the way I got to this is somebody said, well, okay, so you keep talking about what it costs to do carrier-grade NAT, what it costs to buy addresses. What does IPv6 cost? And I kept saying, look, it's totally different for everybody. There's no way to quantify it. And eventually, once I hear myself say it's impossible enough times, I try to think about how it could be done. And I finally said, all right, let's go ask some industry experts, what does it cost to run dual stack? And to deploy IPv6 and then to run a dual stack network. And the people I chose as my experts were the people who had written guidance documents at IETF. So the network operators who wrote wireline incremental IPv6, which I was a co-author on that one. There's a data center incremental implementation document. There's an enterprise incremental. I'm a co-author on that one too. And I asked all of the authors to tell me about what it was costing them, what kind of costs went into their deployment, and then what it cost them to operate the network. So again, two separate costs. What does it cost you to deploy IPv6? And then what does it cost you to operate a dual stack network that's separate from just operating a single stack network? So let's see if I can remember this. When I did this at Nanog, I gave percentages because that's all I had. And people said, that's not useful. You can't compare. 10% of what compared to $30 per user? That's not useful. Okay. So I went to say, for a content provider or a data center or a hosting provider, what's their average revenue per user and what percentage of their costs are affected by adding IPv6? So I asked my favorite search engine, what's the average revenue per user for content? And I got a couple of papers, and it ranged from $1.37 to $468 per user. Amazon apparently makes a lot of money per user. But there was a sweet spot, actually. There was sort of a density of numbers right around $40. Google and Yahoo and a couple of the other major search engine standard content sites were right in the $38, $42 per user range. And I said, well, good. That seems like a good place to start. So if they're doing that, now let's take, say, $40 per user, average revenue per user for a content site. Then the content experts I spoke to said that it's probably your development costs are about 10 to 30% of, when you add IPv6, your development costs increase by 10 to 30%, depending on the kind of application you're doing and what, how low in the stack it's speaking, how creative it is, or if it's just using standard libraries and expects everything else to be at the network layer to be handled by other systems. So I looked at Google and Yahoo and a few other content providers' annual reports, and I said, well, what are their research and development costs? And a whole bunch of gazintas, and the gazotas I came up with is it costs them $6 per user to add IPv6 support. Now, it's really hard to guess how many eyeballs, how many users a Google has. Papers that I said, though, made it look like a billion was a pretty good number. I like billions. Billions are nice round numbers. They've got lots of zeros and even a bunch of commas after them. I like that. So $6 per user. That's hard to believe that Google spent $6 billion. The cool thing is, what's at the bottom there? Capital expenditures are reduced if they're spread over a longer period of time. So you don't actually have to go write a check for $6 billion to deploy V6 if you can stretch it out over 5 years. And then you sort of roll it into incremental work with all the normal work you're doing. One of the things that the content folks kept coming back to me with was the security devices are expensive, and there's still cost out there. This was a really hard one to quantify how many boxes need to be replaced. A lot of this is in fact hardware, and it seems like security appliances have been an area that's been lagging in IPv6 support, where everything else has taken longer than any of us wanted. They've taken even longer. So I get to about $7 per user to deploy IPv6 if you're a content or a web hoster. Hang on a second. So then I looked at ISP costs. And the first one, the biggest one for ISPs was clearly CPE. That's the one that for any ISP that provides any equipment to the customer premise, replacing that equipment with something that supports V6 is clearly a significant cost. what I tended to find is they run between $30 and $90 depending on the ISP and what device you're buying and whether it's a combo device that does a whole bunch of different things or it's a single device. So I kind of went in at $50, but then again, but $50, you don't have to, most ISPs are finding that they don't have to replace all of their devices. They need to replace anything that's more than 4, 5, 6 years old, but anything after that is at least software upgradable to support IPv6, so no capital is required. So that's the significant cost for ISPs. And that's been borne out by conversations with a lot of different ISPs that whether that's exactly the right number, your number again may vary, but there's definitely, that's the significant part of the cost. A lot of people kept coming back to me and said, Lee, you haven't paid attention to the training cost. The training is a major expense for an ISP in their deployment of IPv6. And I had to agree that it seemed like we spent dozens of hours putting together training programs for our staff. And then, of course, our NOC and support staff had to spend some time, each of them, going through the training that we'd put together. And yet, when I multiplied the number of hours we spent building the training and performing the training and paying people to be in training and divided by the number of users, it didn't come out to a significant number. And I did try to do the same kind of number for a variety, for a bunch of different kinds of ISPs. And I still kept coming back down to even a small ISP with just a couple thousand users isn't going to send 5 people to 4-day IPv6 training. That's not the way this works. They're going to spend a couple of hours reading a couple of RFCs or maybe some time on getipv6.info, some of the wikis. You get remarkably smart on IPv6 with just 2 hours of reading. It's amazing how fast you can get to really pretty good. After that, then, of course, incremental, there's a long tail. You never become an expert because the technology keeps changing. So the per user cost for training turned out not to be as big as I had feared. And then for consumer electronics, 3 stages, three different segments of the industry that need to be supporting IPv6, content, network, and client. So consumer electronics, that was actually turned out to be fairly easy because nobody would talk to me. So every time I call somebody or try to look up somebody's phone number at Sony or Samsung or any of the major electronics manufacturers, I get silence. So I said, all right, well, how many coders do they have? How many people do they have who are aware of the network stack on each device that they do? 2, right? It can't be that many, right, who are aware of the network stack. So let's say it takes, let's say for a company that ships 1 million units of some device, they've got 2 full-time programmers that their fully loaded salary cost is $150,000 each. So $300,000 divided by 1 million, boom, 30 cents per device. That's how I got there. Is it real? Somebody give me some real information and I'll report it. That's kind of what I know right now. So the operations costs. I had to make up a new acronym here. So for content, their deployment cost was, when I went into the deployment cost, I said it cost $6 per user because it was 10 to 30% of their R&D costs. So that's what I added in here. It's still $6. It's 10 to 30% of their application development cost. So $6 per user per year, or poopy. I'm hoping that catches on. Yes, I have children. So to operate the network, though, not that much more expensive. So 20. If we guess, so if you look at the entire body of operating expenses that a content provider has, maybe 20% is related to things that are affected by IPv6. Clearly, your power, your cooling, your plant, even your hardware acquisition, people doing rack and stack. All those are OpEx. None of those are affected by IPv6. Only things that are affected by the IP layer, and maybe the layer below and above, which should be affected by IPv6. Therefore, let's say that 20% of their OpEx is affected by IPv6, and it just doesn't increase that much. I mean, basically, if you're already running IPv4 and you add IPv6 on top of it, then to operate that network, it's once you've done a ping 6, you do a ping, and you prove that the network's back working again, right? You like the way that I chose ping 6 before ping, right? Because that's the way you're going to do your troubleshooting. So okay, so it's $0.08, 8 cents per user per year. Really not significant to increased in cost to operate that network. ISPs, what I looked at here was the cost of the network engineering and maybe a QA department or a team, or maybe that's baked into your network engineering. Your operations folks, some of your applications and monitoring folks have to do additional work. Every time you release a new box, you have to test all of the features in IPv4 and IPv6. So there's a little bit of incremental cost, right? You have to test a little bit more. Now, honestly, once you've set up a lab to test a box, the hard part is getting everything plugged in, getting the base configurations, getting the base communication going. Running the same set of tests again for the other address family is not that big a deal. Maybe 10% of your time. It's just not that big a deal. So that's where we get to these kinds of numbers. Consumer electronics operating the network, once the box is shipped, it's gone. There's no cost there, right? Have you ever seen a consumer electronics box add IPv6 support after it's shipped? Please, somebody give me an example. That's what I was afraid of. Therefore, it's free because they don't do it. So, in summary, on this section, what will it cost to run dual stack? Well, it'll cost $7 per user for data center. Oh, I guess I want to go back. I did want to say, when I said content, that cost is in application development. For data centers and hosting, where they're not doing software development, their product is the data center or is the hosting service, not the content that's being provided, not application development, the costs are probably lower. If you're not doing software development as a core part of your business, it's probably not a big deal. So the development cost in that segment of that part of that segment is probably less. So for data center content, I was saying $7 per user to deploy and $6 per user per year. For ISPs, I said $25 per user. I rounded a little bit, and $7.50 per user per year. For the electronics, I said 30 cents per device, and 0 to support after that. Now I tried to err on the high end. When I talked to these experts, they'd give me things like 10 to 30% of costs will increase. And I said maybe 20% of your OpEx will be affected by IPv6. I think all of those guesses are high. So I'm hoping that these are very high numbers. They seem to me to be erring on the high end. Of course, and as I said before, you can reduce these costs in your network by starting 4 years ago. That was a good idea. Hope you did that. And the operational cost is sort of what gets you, because that's recurring every year. So the way to reduce your cost of running a dual stack network is to run a single stack network on IPv6, of course. All right, now let's have some fireworks. So what's going to cost to buy IPv4 addresses? You saw this one. I explained it before. Same chart here. Again, this is not a demand curve. This is if all the addresses that were unrouted, underutilized, were pushed back into the RIRs and allocated at the same rate they were before, that's when we run out. All right, at what price would someone sell an IPv4 address? How many people in here have a degree in economics? Raise your hand. Good, okay. How many people here have taken Econ 101? Raise your hand. Okay, cover your ears. I've done some analysis. I have a paper that is in draft right now. It's actually in the hands of an economist, and then I'm going to put it in the hands of a better economist to make sure that it's making sense. So I've broken down the potential supply of IPv4 addresses into 4 tiers. The first tier is the RIRs. Of course, being a network engineer, I start numbering at 0. That's also where we are. So we're in tier 0, remaining address space from the RIRs. And it costs, depending on which RIR and what size member you are, somewhere between 3 cents and $4 per address, if you were to try and scale it that way. Okay. The number of addresses available as of 4 months ago, it's less now, of course, is about 144,000. It's probably down to more like 120,000 now because, of course, Aaron and LACNIC in particular keep giving away addresses. Tier 1 is unused addresses. And here I'm talking about the ones that when I grepped route views, I saw no entry for these blocks. And I literally went through every possible Class A and every possible Class B and grepped the route views database to see what was there. And I found about 480,000, about a half a billion addresses were not even routed, and that's after I subtracted out something like 7 or 8/8s that were government address space that I thought was unlikely, A, to ever be routed on the internet, and B, to ever come to a market, because the US government and the UK government aren't terribly well motivated by market forces. You can offer them $100 per address, they're probably not going to sell, right? It would take an act of Congress. You, as members of the community, can go to your RIR or your local congressperson. So the reason I've given $9 to $12 as the cost per address is because that is actually what we've seen so far in the market. Milton Mueller from Syracuse University did a paper documenting transactions that had been public and semi-public, and he'd seen address transactions ranging from 9 to 12. I've heard as low as 6, but that was a while ago. I've heard as high as 16, fairly recently in Asia. So somewhere in there, this seems to be the number at which an organization that holds addresses and isn't using them is willing to let them go, at least for now, at least some of them. It's important to say, though, that because the pricing is fairly opaque, this is the cost to get them out, to shake loose addresses. This is not necessarily the price, this is not at all the price that you would actually see on a market. There are several factors that go into calculating price. One of them is the expectation. What do you think you can get for your addresses? Well, this doesn't include somebody who thinks they can get $20 or $50 or $100 for their addresses. The underutilized space is address space where I looked at the legacy holders in particular, but in general, /16 address space. But I looked at an awful lot of address space and route views, and then I went and looked at whether they had additional address space. And here's my logic. Aaron's policy says that if you, as an end user organization, have used 50% of your addresses and are growing, you qualify for more address space. You have shown efficient utilization. So if you haven't used more than 50% of your addresses, you won't go get addresses. One could sort of infer then that there's a significant number of organizations out there that are under 50% utilization, because if they were over, they'd go get more addresses. So throw in some salt and say, okay, another half a billion addresses are underutilized, and an organization could potentially renumber into the top half or the bottom half of their address space and make the other half available to the market. And it would cost them a little bit of money to do that, and therefore their cost to shake loose that address space and introduce it to the market would be a little bit higher. So a few dollars. And I've got some guesses about how much work it would be and what it takes. A lot of the costs, frankly, for Tier 1 and Tier 2 are actually the costs that Mr. Lee in particular was talking about, that are, it's a lot of work to document the addresses for a transfer, to make sure that the records at Aaron are up to date, to make everybody feel secure that the addresses they think they're getting are going to be worth using, that they're gettable. So the additional costs to renumber a little bit to make them available don't increase that much until you get to what I'm calling Tier 3. Tier 3 would be where IPv4 addresses are substitutable. That is to say, you could use CGN or IPv6 instead of IPv4. This is kind of funny space now, because if you say, and this is again came up in the panel here, if you say address space is, we've got 65,000 addresses, but they're all assigned to individual computers in our network, we need to renumber. Now again, we probably are only using half of them, or else we have more addresses. So we need to renumber half of our address space to get us down to using only 500 addresses, and then we can sell off the rest. That renumbering is actually going to take significant work. Now I've talked to a bunch of different brokers, and they've heard numbers between $1 to $3 per host to renumber. So that cost per se is not that expensive. What's really expensive is convincing the CIO to drop whatever else he's doing and put staff on renumbering computers. And he has to be pretty confident that the money he's going to get is going to buy him a Bentley, and not just be a few more dollars to go into the overall budget. So I expect that's going to generate some conversation, because nobody's ever seen that before. One economist has seen that. So that was a guess as to what it would cost, again, to shake loose addresses. That's not what the price is going to be. Here, I'm trying to make a little bit, this is even more crystal ball territory. So what's it really going to cost? So I've got the cost, which is what I said before, not the same as price. Now let's pretend that our supply curve, now again, you map a supply curve by saying at various price points, more addresses will become available. So that's what the previous slide said is when the price increases, then tier 2 addresses will become available. When the price increases more, tier 3 addresses will become available to the market. That doesn't necessarily mean there are buyers. That's when you draw the demand curve. Okay, so here I've taken the 2 previous slides and superimposed them and said, if demand is this high and the buyers are completely price insensitive and will pay whatever the market is at that time, then that's the rate at which prices increase. Fairly flat in 2013, fairly flat in 2014. Oh my gosh, Aaron runs out of addresses and there's a run on the bank because tier 0 is gone, and wow, tier 1 doesn't last very long. Tier 1 actually depletes, I think I said before, very quickly in about a year, year and a half. I mean, it's between 2014 and 2015, and all that $500 million is out of there. And then you start to eat into the tier 2 and tier 3 address space. And the next thing you know, it's 2017, and anybody who has an address can sell it for anything they want to, except that by 2017, nobody's going to be buying addresses because they'll say, forget this, it's cheaper to do CGN at $30 per user, except I'm losing users, so you know what? The heck with the whole transaction thing, we're doing IPv6. Whew. So, resolutions. What will it cost to use Carrier-Grade NAT? I say $30 per user per year. What will it cost to run dual stack? If you're an ISP, it costs $750 per user per year. If you're a content provider, it's $6 per user per year. If you want to buy addresses, it's at least $9 to $20 until 2017. It could even be significantly higher than that. That's the bottom price. I expect it to be higher than that. How can you reduce your costs? There's really only one answer, and I've said it several times. Who wants to say what the answer is to reduce your costs? Owen does. What is that? IPv6. I need an adverb, please. IPv6 only. Running dual stack does not reduce your costs of running dual stack. The only way to reduce your cost of running dual stack is single stack IPv6. I would love to entertain some discussion in the negative minute I have.
Since you work for Time Warner, how's the dual stack rollout going?
We have, I was hoping to have some great news to announce today. We have about 98,000 customers actually running IPv6. Those are customers who have successfully gotten a DHCP-v6 lease, and so they are capable of using IPv6. Obviously, not all customers have equipment that supports IPv6, DHCP-v6, so it's been rolled out to many more customers than that. Anybody here from the press? I think I can say that.
By the way.
Oh, never mind. I have reason to believe that we will be further accelerating our IPv6 deployment.
So for your dual stack numbers, curious, eventually you're going to run out of IPv4 space.
Yeah.
So to be dual stacked, you're going to also have to go buy space. So your dual stack numbers actually will escalate once tier 0 is gone.
I did indeed sort of gloss over the fact that, that these numbers are combinatory. So the cost of running dual stack plus the cost of CGN or the cost of buying addresses. And yes, you get to put them both together.
Yeah, okay.
Hey, should we spend more money or more money? Let's do both.
I'll bite. If the economics, you said we had to ignore anything we might have known about economics, so I'll do that. Okay? And we'll accept the forecasts, although there's room for discussion.
Oh, yeah.
If that's the case, what's the barrier?
Well, right.
Because most companies are motivated by business case, and if those are the numbers, What is keeping companies from doing this like yesterday?
Doing which? Buying addresses or deploying v6?
Deploying single stack v6 like now.
I would guess that, well, deploying single stack v6, that's a fascinating question, because if you go single stack v6 now, you lose some number of subscribers because they can't get to the content that they want to get to, much like in Carrier-Grade NAT. Unfortunately, it's more like Cisco has a fascinating statistics page where they show the relative deployment of IPv6 content. They weight it by how many quad A queries. So they take the number of quad A queries they get for any given site, and then check whether that quad A query has a v6 capable website associated with it. So therefore, the Alexa top 1 website is weighted a lot higher than the Alexa 50 and a lot higher. So it's a really interesting sort of way to do a Pareto distribution of v6 availability. By that measurement, they say that 46% of content in the US is available over IPv6 now. Now, you can also say, gee, but that's only 4 of the top 20 websites. Yeah, but it's 46% of what people want to get to. Sorry, so in answer to your question, the people still want to get to the other 50%. How do you get them there? And unfortunately, I would say, if you want to get either you lose them, do you lose half your customers, or do you lose all your customers because they can't get 50% of the content? I don't know. It's a risky proposition. One way to hedge that proposition is deploy NAT 6.4, but that looks an awful lot like Carrier-Grade NAT again.
When you were thinking about the cost here in regards to Carrier-Grade NAT, dual stack, and IPv6, or single stack v6, whichever you want to look at, I didn't see any numbers included in there in regards to back office systems and the expense involved with developing systems to keep track of all that, be it for Carrier-Grade NAT purposes, logging, CALIA, that type of thing, or just keeping track of your v6 users and how you administer that.
I did indeed neglect to say, but I did include some money for logging systems and maybe additional development of provisioning systems in the CGN case. I didn't say it, but when I did the math, I included an allowance there. I did assume that you would be doing some kind of deterministic CGN or bulk port assignment or something to minimize your logging, not a single log entry for every single TCP or TCP session, right? Because that kind of logging changes the scale significantly. I also included an allowance for systems development in the IPv6 deployment numbers. I just sort of baked it into all the rest of the deployment that needs to be done. And because it turns out to be, from the way I looked at it, roughly the same whether you do in-house development, labor hours, or you buy a COTS tool that costs a little extra, or you have to pay extra licensing. Don't pay extra licensing for tools for v6. But if you did have to, the costs are about the same.
So when you were factoring extra money for predefined ranges of ports and whatnot, did you factor in extra customer loss for the port limitations that get applied there and the non-expandability of port range?
No, I didn't. And the number of, there's a very reasonable question about, I have another spreadsheet coming up, proposed for NANOG, we'll see if it goes, where I include a fractional address as part of the cost of CGN. And then the question is, how many users are you putting behind that address? And so that would go directly to how many ports per user is how many users per address. And so you can do that math that way.
I'm talking about the number of users you lose because they want more ports than you're giving them.
So the question is, how many users do you lose because you didn't give them enough ports? I haven't seen a lot of data on this. I've seen a little bit at the v6 World Congress a few weeks ago that says something like 98, 99% of users are fine at 2,000 ports, I think it was. Maybe it was even higher than that. So, and the deterministic CGN also includes an allowance for if a user tries to use more ports than they have available, more ports will, another chunk of ports will get assigned to them. So no, I didn't include an allowance for that because it seemed like it was way down in the margins. Give me the hook. You better, because I'll keep talking. Thank you.